think I'm streaming. Am I streaming? Yeah, yeah. Okay. Turn down the music a little bit. There we go. Now, double check this one. Okay, well, it didn't do it to that, but at least it's on YouTube. Okay. Welcome to Math at Midnight, Math at Late Night. Today I wanted to go over something real special. A little bit of L'Hopital's rule. Now, L'Hopital's rule is a fun rule. Basically, when you are trying to take a limit of a function, and let's say you divide by 0 because of the limit that you take. Well, you can't divide by 0. So now you know what you're gonna do? You're gonna differentiate. That's what you're gonna do. Let me show you. This says when a limit as x approaches c for f of x over g of x is equal to f of c, g of c is equal to 0 over 0. That can't work, can it? No, it can't. So this is what we do. And take f prime of x over g prime of x. Let's show you an example. One example might be look at something like this. Let's say we take the limit as x approaches 8. But you say, why? Why 8? What does that even mean? Well, let me show you. How about we do this? If we do the limit as x squared minus 6x minus 16 over x squared minus 2x minus 48. Okay. What's one way that we need to do it? we try direct substitution, right? That could be one method. Let's try. Let's say we put in 8. 8 squared minus 6 times 8 minus 16 over 8 squared minus 2 times 8 minus 48. Well, what is 8 squared? 64. What's 6 times 8? 48. Minus 16, right? So we didn't do anything to that one. And we write it again. 8 squared. It's got to be 64. 8 times 2. 16. Minus 48. Isn't that the exact same thing? Yes, it is. Because 48 plus 16 is, you guessed it, folks, 64. Which gives us 0 over 0. I don't like that. Do you? So let's go ahead and let's try something else. Maybe we can differentiate. The top is a function and the bottom as a function. Let's show it to you. The limit as x approaches 8. Well, what is f prime? Well, the derivative of x squared is 2x. What's the derivative of negative 6x? Negative 6. Derivative of a constant's always 0, right? Yes, it is, ladies. Yes, it is. Now I'm going to say the derivative of x squared, 2x again, minus 2. That should be good to go. So, what do we have? Let me look. 2x minus 6 over 2x minus 2. Now let's take the limit as x approaches 8 again. Using direct substitution. And we know what that means. We're just going to input the values. 8 minus 6. 2 times 8 minus 2. Okay. What's 8 times 2? We know that's 16 minus 6. 8 times 2? We know that's 16 minus 2. I believe that's 10 over 14. We can reduce that a little bit more, can we? Let's make that 5 over 7. Ladies and gentlemen, you have just found the limit as x approaches 8 for the function x squared minus 6x minus 16 all over x squared minus 2x minus 48. This is Math at Late Night. Here to fulfill all your needs. Let me know what you want to look at tonight, and I'll put it up on the screen for you. Don't be shy. Here we go. Let's look at another example. How about we show the limit as x approaches 0 of 8x squared over the cosine of x minus 1. Whoa! We just got trigonometric functions. What does that mean? Let me show you. What's one thing we need to do? Well, we could try direct substitution. When we use direct substitution, you know that means we just input the value as x approaches that value. So we're going to get 8 times 0 squared all over cosine of 0 minus 1. Well, what's the cosine of 0? Who knows? I do. If we remember the unit circle. That's right. Always comes back to the unit circle. Cosine of 0. It's right there. Isn't that right? And the unit circle has a radius of 1, making this x point 1, this y point 0. Isn't cosine the x value of that angle 0? Yes, it is. We could draw out a SOHCAHTOA, but I don't think we need to do that. We can just easily point that out, right? Let's show what that is. 8, 0 squared. Cosine of 0 is the x value of that point. X value is 1. We get 1 minus 1. What is 0 squared? 0. Times 8 is 0. So we have 0 in our numerator. 1 minus 1 is 0. Uh-oh. We can't divide by 0. We got this L'Hopital's situation. Let's take the derivative of the top with respect to x. And let's take the derivative of the bottom with respect to x. Thank you for joining. If you're new to the channel, this is Math at Late Night, solving all your problems. Let's take the derivative of 8x squared, and let's take the derivative of cosine x minus 1. What do you think that is? Well, the derivative of the top, you got that right. And 16x. It's 8 times 2, that's 16. 2 minus 1 is 1. And that is our new degree. Let's look at the derivative of cosine. Minus 1. Well, we know that 1 is a constant. And that constant derivative is equal to 0. But what's the derivative of cosine x? That's sine x. So let's see. Can this work now? The limit as x approaches 0, 16x. That's right. We're going to rewrite the function. Over sine x. Let's try direct substitution. Because I always find it very, very helpful to be direct with what you want from a problem. Say, problem, give me that answer, problem. Let's put it in. 16 times 0. Well, what's the sign of 0? Uh-oh. What are we doing? What do you think we need to do? That's right. L'Hopital's rule again. This is 0 over 0. Sine of 0 is 0. L'Hopital's rule. We're going to take the derivative 16x. We're going to take the derivative sine x. What does that give us? 16x becomes 16, doesn't it? Oh yeah. Well, what is sine x? That's right. Anytime you go from sine to cosine in a derivative, you gotta add that negative. You gotta add that negative. You gotta add that negative. Bada bing, bada boom. Let's rewrite. Always good to rewrite the formula out or the problem out one more time. We taking the limit as x approaches 0 of 16 over negative cosine x. That's right. You know what we're going to try and do for the third time in this problem? Direct substitution. That means we're going to put in a 0 for any time we see x. This becomes 16 over negative cosine of 0. Well, what's the cosine of 0? We said that before. It's 1. Isn't this just negative 16? And that, my friends, is the answer to our original equation. The limit as x approaches 0 of 8x squared all over cosine x minus 1. Therefore, we can conclude that the answer, meaning the limit as x approaches 0 of the function, is equal to negative 16 by L'Hopital's rule. You always want to end your answers with a statement. See them 4 dots? Them 4 dots are your friend. I like them 4 dots. That means therefore. Therefore, we can conclude that the limit as x approaches 0 of the function x squared or 8x squared over cosine x minus 1 is equal to negative 16. Draw a good box around that thing. Bada bing, bada boom. That's our answer. Don't everybody feel better? What do y'all think? Is that something that you would like to see? This is Math at Late Night, helping you with all your problems. Drop a like, a comment, or a follow. Maybe even subscribe. You know I appreciate it. Let's try one more. You know it's getting late. But as always, math time here. What's one thing we can look at? How about we show this next problem for everybody to see? Let's take the limit as x approaches 5 of x squared minus 25 all over x minus 5. We got ourselves a 0 over 0 situation, don't we? Let's show it with direct substitution. Now we're going to input 5 because that's what direct substitution is. Because the limit as x approaches 5 means that you need to put in 5 into the equation. Let's show what it is. 5 squared minus 25 over 5 minus 5. 5 squared is 25 minus 25 over 5 minus 5. We have a 0 over 0 situation. It ain't looking good. So direct substitution ain't gonna work. You know we need to call on our friend L'Hopital. L'Hopital. We're gonna differentiate the top. X squared minus 25. We're gonna differentiate the bottom. X minus 5. What's the derivative of the top? Oh, don't you know that's 2x? Again, what's the derivative of a constant? I'll tell you. The derivative of a constant is 0. What's the derivative of x? Oh, don't you know that's 1? Derivative of 5 is 0. 1 minus 0 is still 1. That's our denominator. What do we do now? Oh, you know we got to rewrite. Rewrite means rewrite the problem. The limit as x approaches 5. Now we're going to put in this new function, because that's the L'Hopital's rule, right? If we look at the top, we need to take the derivative of the top, and then apply the limit. Don't forget it. The limit as x approaches 5, 2x. We're going to try that direct substitution. Direct substitution. You know that means that we got to put in 5 for x, right? 2 times 5 is 10. Therefore, we can conclude, right? Yes, sir. And yes, ma'am. Therefore, we can conclude that the limit as x approaches I'm not having a good night with spelling, am I? There it is. The limit as x approaches 5 of the function is equal to 10 by L'Hopital's rule. We can put a nice fancy box around that. And we can be done. I'd like to thank everybody for coming out tonight, watching and supporting the stream. I gotta get to bed. But guess what? I'll be back tomorrow or another night to fulfill all your math needs on the late night. Drop a like, a follow, maybe even subscribe. Let me know what you want to see next. Have a good night, y'all. And I'll see you next time.